why else am I near you? State?
I'm near. That is regressive. I finally found like direct path. Oh yeah, it's very awful. Inside of the page, but it didn't continue until like all the way up the bridge, and I had to circle all the way back. And I'm like freaked out about that.
Hello. I know. All week.
We're at the opposite end of the dinner table.
It's a dangerous game.
Oh, your very last meeting is responsible ID for anything.
Hey, is that not a fun time?
Yeah.
Yeah.
I swear it wasn't fine. My last. Dennis gonna be on.
Yeah.
All right, that one in Toronto. You did take my suggestion to fly here and then to Toronto and then back.
No.
London to wherever we are, Brisbane to Toronto.
Just do a quick round of work. No big deal. Yeah, that'd be just fine. I think not. But this is a unlike the other time. I learned it's a tiebreaker, but
Okay, we need your tiebreaker.
Yeah. Food. What are the choices? Okay, I don't.
Your stuff is
It's like everything.
okay, that's why you and Mexican street on one set.
I've actually, it is actually, it's committed like today. Yesterday.
I actually
Now, if you take 53,
I ended up having this before.
built code and enter the command line like CVC and equal true,
No, I don't think it's probably.
and Google.com already does that. So that's like the easy part is not finding code.
It's probably not.
Well, I mean,
How do you measure the difference?
it won't do anything because like nobody's marking it, but now I can start like putting it.
But do you do address validation next time?
Yeah, hopefully that. Like to finish getting kind of all the stuff so it actually goes into the funnel. Get turned on automatic.
So
You get to this. You get to see.
I phrased it more generally because that's
And if there's
in our specific case, it's a 25 step address validation.
It's really
So the way we discriminate is if you token, it must be a research.
you get the nice sunset. I got a nice sunset.
I don't.
Which
I'm like a blind if I'm around. As I understand, if you don't care about Chrome on that question, for some reason, like I mean, as like protocol guys, like maybe Chrome and you guys network fast.
Yeah, I know.
we've talked about it.
Okay.
But not yet. Yeah. Or I've never actually.
So we
talked about it.
Wait, no, actually, no, there was something weird that I had to. Oh yeah, these guys.
we haven't actually switched on just the logic.
They literally.
No,
And
like
the
the
team
message is like
noticed that wait a second,
QX
we're dropping
instead of QX.
and that's
I
what
changed
turned
that so
it.
that it would match conference. We should check.
No,
We'll check- we'll
not
check
the
after.
sock off or
Yeah.
Because like,
Oh, is that different?
yeah,
Maybe.
so I asked, I asked Tony about this, and he looked up and said, oh yeah, I did.
Okay.
I'd have, like,
They're the
the
type that it takes. Okay, let's check.
Yeah.
It'd be worth actually checking. But all right, we'll do this then.
We
And then we'll check.
dynamically enable
Like what we do.
if the machine is loaded, all connected every tries. So we don't extend any of our systems.
No, I don't think.
If the machine's not loaded, we'll give it time. But I don't, so
It's Friday.
the planet is behaving properly. I don't think it's a reset. Not really a reset. QUIC. Reset tokens, address validation tokens.
Yeah.
I don't know if you saw what I posted on Slack earlier today.
Oh no.
So,
Yeah, it's like one point.
all right, have fun. I did that on Sunday.
Yeah.
Really bad right now.
So, RFC 9000 assumes that the server can always tell the bishop between reset tokens and address values. Because it says if the client is coming to you in the initial with a reset token, it won't process another reset. There's no point
All
in
right.
reset.
Welcome to MASQUE.
Yeah.
The problem comes
Before we get started,
if the client
who wants to take notes? I thought that would quiet the room down. But see, you've got a thing.
when DNS
Yeah, all right.
Oh,
An active excuse, an intent laptop screen. Would anybody like to volunteer to
and then they'll
take some loose notes here?
yeah.
and so hey, there's an information which if it doesn't close for it.
We've got Brian for backup notes. So whoever wants to do notes will have Brian as an awesome note-taking
Yeah,
partner. Thank you, Brian. Got this? Thank you, Mark.
I mean, it sounds like.
Yeah. We'll try to keep it fairly straightforward. Wonderful. Thank you, Martin and Brian. Okay, let's kick things off. Welcome to MASQUE at IETF 119. This session is being recorded. By this point in the week, you likely know how to join the queue and leave the queue. If you haven't yet, make sure you scan the QR code if you're in the room so that you can actually speak at the microphone. Also helps us take attendance and fun things like that. You've also likely seen the note well. These are the terms under which we do work here in the IETF. Please make sure that you actually read it. I know we tend to breeze through it in the slides, but there's a reason we put it up at the beginning of every meeting. And we also operate under a code of conduct in the IETF. So if there's ever a concern, please make sure that you can come to the chairs, you can contact the Ombuds team, you can talk to an AD. So there are definitely resources to make sure that those concerns are addressed. We have some helpful links here, which are probably more useful in the PDF form. And we have an agenda for today. So thank you, Martin. We've got scribes. Would anybody like to bash this agenda? We're going to start with our working group documents, ideally make some good progress on each and some of the remaining issues that need to be resolved. And then at the end, we've got a preview of potential new upcoming work, which is an extension that we talked about previously, but had deferred due to lack of need, for which apparently a need has arisen. With that, let's start with Tommy and Derek. Just Tommy.
Confirm your selection.
All right.
Hello, everyone. I'm Tommy Pauly, and I'll be talking about our draft on QUIC aware proxying. So this is the extensions to Connect UDP to optimize things for QUIC, mainly around allowing it to do forwarding mode to skip extra encapsulation. So this is co-authored between myself, David, and Eric Rosenberg. Unfortunately, Eric Rosenberg was unable to make it to the meeting due to schedule change, so he will not be presenting. So you'll have to forgive me for the second half of these slides where I am less prepared because I was not planning to present them, but we'll go with it. All right. So what are we going to talk about today? First, I'll just quickly recap what we're talking about here in case you haven't been following along. But then the most important things are we have the design team that we'd had for quite a while that was working on how to add encryption to the forwarding mode. And hopefully we can converge on closing that design team today. I would love to see that. And then we also have our other major issue from Martin Duke, that is our loop issue. And hopefully we'll have a way forward there also. So help us along here. All right, so as a brief recap of what we're doing, so we have connect UDP, the client tells the proxy extra information about the quick connections it has, specifically the CIDs, and the proxy knowing about what CIDs are being used between the client and the target allows it to do fun things. It allows it to reuse ports and use connection ID demultiplexing. It allows you to say, hey, our outer packets look all like quick short headers anyway. Let's just not re-encapsulate them and have them all on the outside and avoid extra overhead of losing our MTU there. And so that's referred to as forwarded mode. And then in the current version of the draft, we have a notion of virtual CIDs, which are the CIDs used between the client and the proxy for the packets that are indeed then forwarded onto the target. But, spoiler alert, the rest of the packet that is being forwarded is not modified yet. So here's a basic look at one of the ways you can use forwarding mode in terms of how we use MASQUE for private relay when we have 2 hop proxies. What we do is we do forwarded mode across the first hop proxy and then kind of terminate the tunnel at a second hop. And then the second hop does kind of full tunneled mode all the way to the end. And then leading into the issue that we're trying to fix with the design team, the concern, which is very valid, is when you are using forwarded mode, it is a lot easier to have someone passively observing both sides of the proxy. And even though the connection IDs are changing, you can recognize the content of packets on both sides and then infer more information about where it's going. In some cases, like when you're just having a long chain of proxies that's relatively deterministic, that may not be interesting, but it's not a great thing to be forced to leak. So that's what the design team was looking at. All right. So we had formed the design team to analyze the threat of traffic analysis on forwarded mode, especially when compared to the normal connect UDP tunneling, and to propose a mechanism for adding encryption when you're doing forwarding. And so there is a pull request out, pull request 99. You can go look at it if you want to see the whole content. In the GitHub, it has like a rendered view, so you can like look at it in a pretty form. So the overview of the solution is there's a notion now of packet transforms that are negotiated when you are going into forwarded mode. And we define specifically a new transform called the scramble transform. It uses AES 128 block ciphers and it scrambles up the bits. And I'm not going to put all the details on this slide. You can read it in the pull request. We believe it works. Thank you, Ben Schwartz, for figuring out all of the bits we should do there. And this means that when you look at the packets on both sides of the proxy, they do not look the same. Note that this does not solve anything about packet size or packet timing analysis, which is also a very easy way to do correlation, but that is a problem that goes beyond this particular area. And so the goal is to prevent passive byte recognition. And some of these other attacks that you could have that are passive around timing, you also have with any kind of normal or naive implementation of tunneling. And we also note that various active attacks of cases where you're able to drop packets or inject packets or duplicate packets allow you to learn about the correlation of a flow on one side of the proxy and the other side of the proxy, regardless of doing forwarded mode or not, regardless of doing scrambling or not. So if you just want to see how the transforms are negotiated, essentially it's this little bit in bold, got modified. Instead of just having the header that says, I do forwarding, we add some transforms about the transforms you support. We're renaming null to identity. Thank you, Martin, for teaching us the correct pedantry around transforms. You're absolutely correct. The identity transform is the right one to do. The null transfer would make everything 0. Not a particularly useful packet forwarding mechanism, but yeah, I guess we could define that one too. It has very, very low throughput. And then we have a key that you use for scrambling. And then on the response, the proxy can say, yes, I also support scrambling, and here's my key that I use. And as I've mentioned before, when we've talked about this overall protocol, both the client and the proxy have to agree to doing any type of forwarding mode or any type of transform. Otherwise, you are going to get your normal tunneled mode. So if you don't want to do this type of thing, don't do it. You don't have to do it. It's fine. Okay. Just noting that this proposal doesn't have an explicit transform that allows you to add padding or chaff or other timing things. Talking in the design team, I believe it is possible and certainly doable that we could define other transforms that would allow you to both scramble and add padding. But we agreed that essentially like figuring out the right schemes for how to add chaff or timing to really stop traffic analysis is a much bigger research project that is not appropriate to try to stuff into this document. And so that is extensibility work that new documents can handle. All right, I see we have a queue. Do you want to go to it right now? Happy to. Brian.
Yeah, so this is a clarification question here. I think I might be restating something that you just said, but maybe also not because it's quite early here. So a transform is capable of mapping M input packets to N output packets, correct? It's not like a one-to-one mapping between the input, like for every packet that's incoming, I don't have to generate exactly one packet outgoing, correct?
Correct. The transforms that this document defines are one-to-one, but there's no requirement that all transforms would be one-to-one.
Cool, then we can let this be future us's problem.
Exactly.
Great
clarification question, though. This is good to point out. Martin.
Martin Duke, Google, no hats. So it seems like it is true that even in tunnel mode, you have to like design stuff. But with tunnel mode, you can simply add padding.
Yes.
Whereas, I mean, I haven't read the PR, but it doesn't sound like you can sort of arbitrarily add padding to like the core packet. Or maybe you can. Can you?
The proxy cannot. Like, I mean, you can't add padding that is only added on one side of the proxy connection.
Which is not the case in tunnel mode. So this seems to be a bit of a downgrade in terms of your ability to obscure stuff.
Right, correct.
Okay.
If you stick to this transform, I think our analysis was it's pretty trivial to design a transform that lets you do that. We just aren't specifying it here because the way to use it correctly goes far beyond what we want to say.
All right, fair enough. Thanks.
Potentially pointing to, like, I don't know if it's engineering work. It's almost more like research work that like someone should talk about how do you do good padding chaff techniques for these types of tunnels and actually analyze the impact on analyzability. Okay. So next steps here. Actually, we've already merged a couple PRs against the design team PR. So we renamed null to identity. We added some extra text into the security considerations talking about the active attacks. At this point, I think the design team is happy. I'd like to get the chairs to like close our design team, maybe get consensus to merge this design team PR into the document so we can move forward. What do people think?
Barring anyone hopping into the queue. Oh, hello.
It's not going to be that easy.
It's a hike, man.
You should move it up.
It's a hell of a big room. Just because I haven't double checked, can you repeat transforms?
Can you what?
Can you repeat transforms? Can the client say, I accept this set of transforms? Presumably they advertise a set of things. Can the server say, I would like you to transform using the scramble transform 5 times. Now that one doesn't make any sense, but what if it's something else?
I don't think the semantics of this allow that. What are you imagining?
Can I jump in here?
Please, Ben.
So the semantics are modeled on the accept header. So the answer is currently no.
Yeah, I think that would be a mistake if you're talking about the sort of generality that Brian was asking about, because there's always the possibility that you might have sort of compositions of transforms. So you have a simple transform that you can compose. That does make things more complicated, though.
Right, because you could also just define like scramble pad, scramble plus this. Like you just have like
right.
It becomes a combinatorial explosion, but at some
that might be easier to deal with than saying you have to apply this transform, then this transform, then this transform.
Right. Because realistically, I imagine there's going to be sets of overall transforms, which may themselves be composite in a way, but that are like, this is a thing that makes sense to do in a deployment, and we don't need arbitrary composition.
Yeah. So one of the compositions that I imagine you might find interesting is please put a length prefix on the front of this thing. And then the next transform is please take 3 of these and jam them in the same packet. That sort of thing. So you can have this arbitrarily complex, but it sounds like we don't want that. We just want one.
Right. I think instead we would define a complex transform that would know how to pack packets.
And the proposal there is that would just be a differently named transform for the combinations that make sense.
Correct.
Thank you. David.
David Skenazy, +1 to what you both said.
Okay. Thank you.
Yeah, Kulevin, just to clarify, I think we should actually say you can only apply one transform.
Yeah.
But actually, that brings me to another question. Can you can only apply one transform to one packet, but can you somehow apply different transforms to different packets for whatever reason? I don't know.
So the transforms come along with other parameters, like scramble comes along with the key. So I certainly imagine you could have like random chaff transform or like random padding transform that says apply this algorithm for creating these size packets, and not every packet will have the same padding added to it. Like they may, there may be some randomness in there, but that is a property of the transform as a whole, and maybe there are parameters to the transform that tell you how to generate the correct patterns.
Okay. Yeah, then the answer is no. You always apply one transform to all packets. That's it.
Yes. Great. Good clarifications there.
All right. So it sounds like we think we're ready to potentially, barring any additional feedback this week, let's run a consensus call against the output from the design team and then merge that. I'm seeing some thumbs up from some of the crowd. With that, I do also want to say thank you. We had a nice pile of about 7 people who are working on this design team. So thank you all for the extra time and energy to go away and solve some of this in a way that's harder in a larger group. Cool. So cool. All right. So we will run a consensus call on that. And then assuming that we end up in good shape, we will close the design team and
thank you.
Send you on your merry way.
And I'll point out that, of course, this is not the end of this document. Like there's, this is just, to merge it. And one of the things, once we merge this in, I think we need large editorial paths to make things much clearer now that this is in here and kind of rewrite the flow. So I'm eager to see this merged in so we can try to rearrange the whole document and make it much clearer now.
Great. Speaking of next steps for some of that, one of the other questions that's come up is just kind of implementation status. Is there anybody who'd like to wave their hands or pipe up in the chat that they either have an implementation or are thinking about having an implementation? I see some hands. I see some hands.
Yeah. Well,
and I see a head.
Yes. So now I think at this point, the implementations, I know like Erickson, and I guess David, like have the current draft. I don't know if anyone's done the transform yet.
Right.
So I think the next, you have? Oh, great. Awesome. So Marcus said that Erickson's implementation implemented the transforms in the hackathon. I still need to catch up on that. But let's do interop testing on that.
Great progress. Thank you. Excellent hackathon.
Okay, moving on. So I just wanted to talk about one more issue on the document, which is loops. So if you haven't read the issue, you can go to issue 88. I think this is the one that Martin Duke filed. Clients could be evil if you have like a long chain of proxies with forwarding going on. They could craft the virtual client IDs they're using to cause infinite loops between proxies. When the proxies share a client-facing IP address with other conceptual proxies, or just kind of like themselves. And this is also dependent on proxies reusing their sockets, their 5 tuples when they're forwarding traffic. So essentially they are unable to distinguish kind of which stage of forwarding they're in. And so things blow up, it's bad. I don't think anyone has actually like built a scenario like this yet, but it's definitely possible. And we don't want to build a little time bomb here. And so again, these are not my slides. This is Eric Rosenberg's thing, but I'll try to speak to it on his behalf. So he's opened up a PR on this, I think. Yeah. So he's opened up a PR that tries to solve this with one of the approaches. I think the issue lists, a couple of different ways you could handle this. And the solution in PR 104 is to say that the virtual client CIDs, so the virtual CIDs that are used in the direction between the proxy to the client, that those need to be chosen by the proxy. And today they are chosen by the client, which is a nice thing when you think about like, oh, you get to choose the CID that you receive on. But in order to avoid the loop, having the proxy choose that during the negotiation is one way to break this looping problem. So the main question is like, are we okay with this solution? It does add a bit of complexity. Like we use capsules to negotiate all this stuff anyway. There technically is like another capsule you need to do because so today, before this, we have the client registering its CID to say, hey, I've told the target that I'm going to receive on this connection ID, and here's the virtual connection ID I would like the proxy to send to me on. And then today, the proxy would just say like, yes, I see that virtual CID, I will use it. In this variant, the client sends you its real CID, and then the proxy determines the virtual CID to use, and then the client needs to acknowledge that virtual CID and make sure that it's willing to receive on that. So it does add a little bit of complexity there. However, the nice thing is that this doesn't overall add any back and forth to the number of round trips that you need to get to forwarding mode, because you already had to have another round trip to negotiate the target CID once you learn what CID was selected by the target. So it adds complexity, but it does not add time. It's just a number of bytes that you need to process and an extra check to do. So it's not like super elegant, but I think it's the clearest solution. It's the most tangible solution we have to this problem right now. So what do people think? Alex.
Alex Chernohovsky, Google. Sorry, clarifying question, because I seem to recall the last time we talked about this. The problem with the solution that I seem to remember us having is this would work except for the part where we can't ensure the client actually uses the proxy's chosen connection ID. How are we ensuring that the client actually uses the connection ID that the proxy says it should use?
So this is the connection ID upon which the client receives packets from the proxy, right? So the client has told its real CID to the target, so that's fine, right? And this is just like when the proxy receives a packet to that real CID, and now it's going to apply the transform, right? It's it's going to scramble all the bytes and it's going to slap a different CID on there. The proxy is saying, I'm going to put this other CID on your packet. The proxy chosen virtual connection client ID. So the client doesn't really have a choice. The client can acknowledge like, yes, I'm willing to receive on this CID, and it can say like, no, proxy, like this is not good for me because it conflicts with another CID I have. But it's the proxy is just going to send on it. There's nothing about like the client not using it correctly.
But what's stopping a client from sending sending packets with that same connection ID and thereby recreating the loop?
You only receive on, so this is only applicable to short header packets. So this is only downstream.
Okay, thank you.
Yeah. Yeah, so I think like overall, and correct me if I'm wrong, Martin, like the loop is downstream packets. It's like the client sets up the virtual CADs such that when a server starts sending something, it ends up just like spinning out of control.
Right. I haven't thought about this in a couple of months, but if I recall correctly, since the client essentially, if you have a daisy chain of proxies and the client is essentially setting all the virtual CIDs in the entire chain in both directions, for hop n plus 1, it says use this CID to send to hop n, but it tells hop n you will receive a CID, this other CID for this loop, but n plus 1 is sending from like from a different hop in the path, and so n gets confused about where it's receiving it from. So you're essentially telling two proxies who are talking to each other in the chain, giving them different CIDs to use on a particular virtual link, and that's where this arises. So if the downstream proxy is not getting that from the client, that should solve it, although I should probably read this and think about it some more. It seems like it would solve the problem. Yeah. I don't know if there's an issue, if anyone has a deployment where client CIDs are important for routing or not. That would be the only real problem I could see on the face of it.
Right. Miriam.
Yeah, I just have a question. Are you just applying this if you believe there's an attack, or when do you even use it?
No, this would change what you do all the time.
All the time, okay.
Which it adds a capsule, but it doesn't add time. So, yeah, I think from the perspective, like on the client, because I think mainly the complexity is for the client to have to now accept a virtual CID from somewhere else. Practically, at least in our implementation, like you only set up the mappings and like the forwarding rules once you've finished this entire negotiation anyway. So it doesn't really change too much. It's just like where the bytes come from. Martin. It's so long.
Hello. I should just move. So does this create the situation where on the virtual connection ID side of things, the client chooses the connection ID that it sends with, and the proxy chooses the connection ID that it sends with, which is the opposite?
No. It creates the scenario now where the proxy chooses both.
The proxy chooses both.
Because today, before fixing the loop thing, the client chooses what it receives on, the proxy chooses what it receives on. Standard QUIC. This modifies it such that the client no longer gets to choose what it receives on, or rather it gets to acknowledge it. It gets to like argue about it, but doesn't get to actually choose the CID.
Right. Doesn't that constrain your client?
Yes.
Port allocation strategies.
Yes, it does.
Things like that?
Yes, that is the trade-off of this. And so it's like, how painful is that constraint? I know that's why I don't think this is elegant, but I don't know a better solution.
So David Skenazy, just for what it's worth, it's a mess kind of in all cases, because conceptually in QUIC, any endpoint chooses what connection ID it receives. But the second you start doing connect UDP and you proxy, the client's packets are now popping out of the proxy. So in regular connect UDP, we don't have that problem. But with QUIC Aware, now you can have the client's packets come out of the proxy's address, and now the client is picking the packets that go to the proxy, and that's the case here even before the attack. So whichever way you look at it, it's going to be wrong one of the ways. It has to be.
Well, even without forwarding,
with forwarding mode, we have this bug as well.
But even without forwarding, like when a connect UDP proxy is sending packets up, like it's receiving packets on a client chosen connection ID It's just not
Well,
a
no-
quick connection there. It's just a UDP socket.
That's right.
Yeah.
But if the second you put forwarding mode and you merge those two sockets on the proxy now gets packets from the target to the proxy aimed at the client using the connection ID chosen by the client, but that's landing on the proxy.
Just to be very nitpicky here, it's not when you enable forwarding mode. It's just when you enable quick aware at all, right? It's like the moment you tell the proxy, here are my CIDs, I'm letting you know how to do socket sharing, port sharing. That is based on client chosen CIDs now at the proxy.
Yes, I'm realizing that maybe we should, I don't know if it warrants a design team, but at least a smaller group, because this is enough of a headache that we might want to take it offline.
Yeah, I mean, I think this is a good solution. What it makes me realize is that the ugliness that we're adding here is actually just like payback to the client. So, right, because the proxy already has to deal with receiving client CIDs, and now the client has to deal with receiving proxy CIDs. So it's, yeah, okay.
All right, Mary is in the
Mary.
queue.
Yeah, one more question because I probably didn't read the PR. Can that not lead to conflicts for CIDs at the client side?
It could, and if it did, you would instead of acknowledging the client VCID, you would close the client CID and say, sorry, I can't forward like this.
Okay, and then you might open a new connection, start over again, or whatever.
Or no, or you just say, I just keep on tunnel mode. Like it should be very rare.
You can stay on tunnel mode.
Yeah, exactly. Like until this finishes, you have a working connection anyway. You're just not forwarding. Yeah. Okay. That is the end of the slides here. Read this PR. Chime in on the issues. That's it, Martin.
Yeah, so just one last clarifying question. So we've been saying, clients can't route by CID. Is that going to be so this is also true of upstream and downstream confuses me. Earlier, proxies in the chain on their target-facing interfaces, we don't think we're having deployments where there's routable connection IDs. Because that's actually where this arises, not really on true clients, as it were.
It's correct.
Okay.
And already there, the proxy can only choose to share ports or share sockets when it is guaranteeing that there are not conflicting CIDs. It already has to manage that. Or if it doesn't want to manage that, it just has a unique socket per.
Right. Okay.
So it's fine too.
So remind me, in Connect UDP, we do not give the proxy a veto on the client CID.
Well, there's no veto on the client CID. Even here, it's so in normal Connect UDP, you must have a unique UDP socket for every Connect UDP request. This allows you to scale differently, but the trade-off for scaling differently is you need to be aware of the CIDs, and you need to, if you have a conflict, you need to have a separate socket.
Okay. Yes. Thanks.
Which is the same thing on the client now. Yeah. Okay. Let's move on. Thank you for the input.
Thank you. All right, up next we have Abhi. So we'll send a consensus call for the design team output, but for some of the CID discussions here, it'd be good to get a few interested folks together in the hallway over the rest of this week and see if we can nail something down.
All right, so hello everyone. My name is Abhi Singh from Google, and I'll be presenting Connect UDP Bind today. Yes, it's called Bind now. We've changed the name. Used to be called Listener, and I'll talk about it in the following slides. But first, I'll go through very quickly what Connect UDP binding is. It's that, you can use a single connection to go for multiple targets. So in traditional Connect UDP, you could only select one target, and but here what we do is when you specify the Connect UDP listen header, it will be called Connect UDP bind now. In each datagram, you add the IP version, IP address, and UDP port to specify which target you want to reach. And likewise, the proxy will in return do the same thing to say which target it received this packet from and is forwarding the packet from. So yeah, as I said, from client to proxy, it's the target IP port per payload, and from proxy to the client, it is the source IPN port per payload. Well, so I'll talk real quickly about the changes we've had since last time. We renamed ConnectUDB Listener to ConnectUDB Bind after having a discussion here and also on the mailing list. And this seems to be a general consensus that this name is more appropriate. Secondly, we just this is a small change. We changed the sorry, the header to ConnectUDB Bind, like with camel case, to be more compliant with how HTTP fields are assigned. And so I'll talk about the pending PRs now, and these address some of the previous issues that were discussed in previous IETF sessions. So the first one is adding the IPN port to the response header. So when a ConnectUDB bind request is made and the response headers are returned, now we propose to add a proxy public address header in there, a response header in there, and it can have up to 2 IPN ports, so IPv4 and v6 respectively. And so this way, the client knows which public IP endport it has been assigned, and it can use that for its purpose. Yes, Ted Hardy.
Sorry, you were much quicker at answering the queue than I was expecting. I just wondered for the v6 whether it would make sense to permit a prefix rather than a single v6 address, since a v6 host may in fact be using a prefix to select from a variety of v6 addresses.
I'm not. I don't think it makes sense to do that in this case. I think it. Sorry, go ahead, David.
Okay, if you don't, I just want you to think about it, because obviously with privacy addressing, many hosts do change their outbound addresses at different times. So depending on the model of the deployment, you might actually see that. Now you may have a mechanism for them to update the proxy public address, or you may say they can't do a change if they've got an active connection using that proxy public address. But it's actually not very v6y.
Ted, just jumping in as co-author. So the idea here is that the goal of getting the client this address is to then it can communicate with something else to tell it that's how you get back to the proxy, which will get back to me. So you can a prefix wouldn't work for that.
Okay. Well,
so when you bind your socket, you've committed to that address for the purpose of this request.
Okay, thank you.
Go ahead, Tommy.
All right, Tommy Polly Apple. Yeah, so I mean, kind of on that point, because this, as far as I understand it, is not communicating these are my public addresses in general. It's saying I have bound a socket and I have now allocated you this address and port, and maybe it has v4 or v6 because you can support both of those, but like you now have this instance. It may not be the same addresses you get when you do another bind request to the same server, even in the same HTTP session. So I'm wondering, I haven't thought this through, but it's like, should this just be a proxy status parameter? Because like we already have proxy status that comes back that tells you, here's the remote IPs I picked, here's all these other things. Adding just another parameter that's saying, in my overall proxy status, I assigned you these local addresses, seems like it just fits better than having a whole new header. And we already have the semantics to understand that proxy status is saying, like, this is a proxy telling you what you got for this one request, and maybe it's more clear than saying public address, and you could have the misconception that this is like my generic public address for all things.
Yes, I suppose that works. And there was another discussion I remember, which was about do we want to make fix this address permanently for the given stream? And sorry, go ahead, Jonathan.
I was actually, I mean, go ahead. I'm sort of tangenting a little bit based on what Ted said. So if you're addressing this particular thing.
Okay.
Yeah. So yeah, I mean, I was thinking, given what Ted said about privacy addresses, I wonder if it'd be useful to have some flag that says, give me a unique v6 address that hasn't been used by anybody else before. So because if you want a new v6 address for privacy addressing purposes, then it would, in particular, it's not one that you've used before, but you don't want to be able to say who you is for these purposes. So just one that no one's used before is probably an easier semantic. But why do people want to do v6 privacy addresses?
I am getting a workout this session. So in general, the reason people use v6 privacy addresses is that your host does everything on the same address, so you want to change them periodically. In this case, we're talking about proxies that many users are sharing a pool of addresses, so you don't really have a need for that as much, because the idea, if this is a kind of privacy preserving proxy like the ones we are deploying, every connection is going to get an address from that pool, and it doesn't matter if it's the same one or a different one. You don't need one just for you, and you actually, on the contrary, want one that's mixed.
Okay, fair.
All right, so
should we think about some clarifying questions, or should we move through our 11 remaining slides in 12 minutes before we get deep into our discussion?
Okay, I'll take the last one and before we move on.
It's a clarifying question. What is the actual format of that header? Like, you've got an example, but is it a list of what? Like, to Tommy's point, maybe it would be better if this was articulated via like a structured fields dictionary where you had the v4 and v6 keys that told you exactly what type. Because my understanding of that, it's a exactly one of v4 and v6, and
that's right.
Yeah, if you're kind of like, if I put them in the wrong order, you're going to blow up. Like,
Lucas, have you read the PR? It's pretty, the format is defined in the PR.
I'll read, but if it looks like that, like, I'm going to fuzz you and break it. Like there's much better ways to structure that, in my opinion.
Yeah. Okay, I'll move on to the next address. If you do want to interact more about this, like, we can have a discussion, and also please interact with our PR and our GitHub. And this is the big one, which is compressing away IP endpoint. I've talked about this a bit before, and Tommy had a very interesting suggestion that actually kind of helps us do two things at once with the compression. And I will explain that in a bit. So we want to do both compression and the IP restriction stuff that, oh, maybe I don't want to listen from all addresses anymore. So this kind of, this PR that I have potentially addresses both. So the first one is, so we're defining two new capsule types. There's the compression assign capsule, and it requests the use of a context ID for a single target. So once this compression assign has been exchanged, future datagrams would only need to contain the context ID, and they could skip the IP port. It will save a few bytes. And so there's another type of compression assign that we're defining here, which is an uncompressed one. So if you set the IP version to 0, we use that context ID to reach any target. So now you could have context IDs, a context ID that could be used for uncompressed targets, and then define more context IDs to for just specific targets, one target per context ID. And so this is how it would look like. So there's a compression assign, the length, that's just capsule, that's the capsule format. And then there's the target information with IP address UDP port, the same things as what we had in the initial draft with the datagram. And so to accept this compression assign, the other party would need to echo back the compression assign. So what we're saying is both the proxy and the client can do compression assigns to save on data, and they would need to echo back to confirm that that the compression assign has been assigned, and they both have the mapping for this context ID. And so, but you could send a compression assign and immediately start sending UDP datagrams, but knowing that they might get dropped until you get the confirmation that the compression assign has been accepted. So we have another capsule we call compression close. And this is another kind of response that you could get to compression assign. So if you want to reject the compression assign, you say compression, you reply with a compression close with the context ID of the compression assign. And this could be done to, if they do not want to allocate the memory for this specific thing. Let's say that there's restrictions on memory. And compression close can also be used for another thing. It can be used as a request to close an existing context ID. So if we had, let's say we had a context ID that was open to accept from any and all targets, and I want to close this now since I've exchanged all the information I needed, and I know all my targets that I want to talk to, and I have already assigned them context IDs. I can just simply close traffic from all unknown destinations by sending a compression close for that specific context ID. And another thing, another specification here would be that compression close for an so compression close could be used to free up memory by the proxy as well. So the proxy can also send compression closes. So if a target hasn't been talked to in a while, the proxy might do a little cleanup. Yeah. Yes. So I have a little example here. So there's a compression assign being sent, and it says IP version 0. So I want to use context ID 2 for uncompressed targets, and then after that, all datagrams will contain. Once that is exchanged, all datagrams contain the IP version, IP address, IP UDP port. And likewise, let's say if I did a compression assign with context ID 4 and I specified the IP version, IP address, UDP port. In the future, I'm omitting that information. And so in this example, when we're doing a compression close, and it gets confirmed, the proxy will reject any traffic that's from an unknown target. And that's the entire new pull request. I would like to discuss this with the group. Martin, please.
No. So having close act from both endpoints is something that we learned in QUIC doesn't work very well, because you end up in a situation where one side thinks the thing is not there and the other one doesn't agree necessarily. So there's a risk here if you have the same message sent by both the client and the proxy, that the status of the compression context isn't clear. Now, if the use of the thing is only in one direction, that's fine. That may make it a little simpler, but you have to, I think, treat one or other as a request of the primary actor. So I think if this is, I'm as a client setting up a compression context to send in a particular way,
right,
then I should be the one to close it, because then there's never really any ambiguity about the status of that context from my perspective. Whereas if the proxy can close it while I'm in the process of using it still, then we have a problem.
To answer that, the way you can make that work is you can treat even though the same ID is used for both directions, you can treat your state as unidirectional. So when you send a close, you put it in a, I am no longer sending with this, but I can allow receiving with it until you receive one. And then kind of vice versa, where if you first receive it, if then it means, okay, I will no longer send with it, and you also echo the close. And these are closers sent with capsules, so they're guaranteed to eventually get there.
However, they get reordered with respect to the actual
Yeah.
UDP.
And if you get a datagram where you don't know the compression, you drop it on the floor.
Yeah.
So let me get this right. Both sides have to close.
Yes.
Every time. Well, what Jonathan asks, what if they don't? And I think the answer is, that's great. We have ways to deal with that in protocols typically, so we will execute the usual thing. Okay, that wasn't clear.
Oh yeah, sorry, I didn't clarify that there. As you can see, there's a response for compression close. So compression close can either be used as a response to the compression assign, or it could be used as its own request to close an existing context ID, and it has to be replied back. It has to be echoed back with the context ID. Do we have
Ben?
Okay, Benjamin Schwartz.
Hi, Ben Schwartz, Meta. So I'm a little confused about using the compression context to represent a firewall. Just my reaction, my gut reaction is like this: you're mixing these two things in a way that's going to get really confusing. It's going to be very hard to do things like say, I'm garbage collecting this old allocation, but if because I don't want to build up an unlimited number of these compression contexts, but I don't want to block packets from that endpoint. I'm just not expecting any right now, so I don't want to waste space on it. Things like that. So I think that you are going to want a clearer distinction there between opening and closing these compression contexts and blocking certain categories.
So my understanding is, would you like to have a separate category of capsule in this case, I guess, to define what specific use case it is?
There are a lot of different ways to spell this, but in terms of state machine, basically, I should be able to open some contexts and then kill them again and get back to whatever state I started the connection in, right?
Right.
I should not be stuck on some sort of one-way treadmill where I can only add new contexts. I can never get back to the state that I started in.
Mm-hmm.
All right, I think I'm next. Tommy Polly. Overall, I think this is interesting. I think it looks good. I need to think about it more. It's a little cute to combine everything. Not necessarily bad. I had a clarifying question just to understand. Maybe if you go back,
sure,
like to the first one, actually that one, yeah. So my understanding is like in the current spec, before we have all the capsules, we with a header say this is my context ID.
Yes, that's right.
The context is not allowed to be 0 because 0 is reserved for the standard connected UDP that doesn't have addresses in it.
Yes.
So when we do this, do we get rid of the header?
So that's a good
or
question.
Do we have the header and the capsule? Like, why do we need the capsule up here?
That's a good question. We could, we just have this spec that this is connected to be bind, and we could just not have the value is the context ID, right? We don't. We just need to define that this is context. This is bind, so that could be removed. While in the hackathon, I was thinking about that exact thing.
Okay.
And The other thing that could be done, I don't know if there's any use for it, which is just, oh, this is going to be the first context ID as I assign. But I don't know. I don't think there's a use for it, so it might just be better to remove it.
Yeah, I just want to make sure there's only one way to get that initial context ID.
Right.
And I think if we look at the precedent of Connect IP, we have cases where you send capsules pretty much always off the bat.
Right.
And that's not bad. So let's just make sure there's one way.
Yes. Yeah, that makes sense. While working on the draft, while implementing it, I came across the same exact thing, and it will be changed in the PR event. Yeah. Miria?
Yeah, just a thought on this close thing. That sounds to me like this is actually something more generic, that if you want to do it, maybe you also want to do it for other cases where you use capsules. So I'm not sure we should specify it here, but I also feel like I'm not sure we need it. If it's only to clean up state, then maybe it's easier to just close your connect and do a new connect and start fresh or whatever. For me, it adds a lot of complexity that not sure I know if it's needed actually.
I think the part of the benefit here is the IP restriction part, which we've been through several times, and I think it's that added benefit. I personally feel makes it more worth it to do this, over if it was just for one of the two things. But I don't know if anyone has any opinions on this. All
right. We are cheerfully at time. Thank you, sir.
All right. Thank you very much.
Wonderful. All right. A quick reminder, if you haven't yet scanned the QR code, now is a great time. While we get set up for our next presentation, we can start an audience participation activity, give it a little stretch, get ready for our next awesome presentation here. All right. It is definitely awesome. No pressure or anything.
We'll start with the pressure of where did Lead Echo go?
All right, take us away.
Out of the show of hands. I've been told I've not been great at talking into the mic, so if I'm not, please let me know. Slides are over there. All right. Back for more Connect Ethernet. There hasn't been actually any change to the draft, but we have a bunch of issues open on the GitHub now. It'd be great to work on them some. We are still in the adopted-ish state, waiting on the recharter. That is in progress. As opposed to last time where it hadn't started yet.
We think we are now in the home stretch, but I don't want to jinx anything.
Yeah, it could fail. It could succeed. Yeah. We'll see what happens. Between IETF 118 and now, we had our coordination call with 802. They seem to not have a problem with this, which seemed to be one issue, one point of contention last meeting. We'll get some feedback from them early. We'll get some feedback from them later. But it sounds like we can move on without worrying about this being called Ethernet terribly much. And here are the issues that I have that I pulled out from last meeting. We'll go over them one by one and see if we have some discussion. We'll start with the big one. MTU and fragmentation. So we're tunneling, which means we're eating up MTU, which means we don't have Ethernet's standard 1500 or for the payload. We don't have the standard Ethernet MTU. This may or may not be a problem depending on the use case. We've got a couple options and neither of them are great. We can fragment. We can drop if things are too big. I suspect people are going to want different things there, so this may need to be a knob we can tune for a given connection. We can also start being somewhat of a middle box with some deep packet inspection and doing our, trying to adjust the existing connection or connections as they're being set up to fit within our MTU. I haven't done anything on this yet, but I hear other layer 2 VPNs have done this successfully. This shouldn't be part of this protocol, I don't think, but it may be a recommendation to implementers. Like the smarts side of this may want to muck with things a little bit so that you're not dropping packets.
It might be good idea to look into practice of previous Ethernet encapsulations at IETF. VXLAN comes to mind. I believe it's just dropped if MTU is too big, and it's really down to implementation to do MSS clamping or something more creative.
Brian?
Hi, another clarifying question. So is this, there seems to be an assumption here that the idea is that we're using this to encapsulate IP traffic over Ethernet as opposed to stuff that is non-IP over Ethernet. Is that the case? Or are we basically just sort of like bridging to IP networks at layer 2 using this? Or is this for traffic that is non-IP?
I am happy for this to cover non-IP traffic. I have ideas for how to help with this issue for IP traffic. Okay. I haven't looked into how to fix it for non-IP traffic.
So the fact that we're looking at sort of like PLP, MTUD, and things like that for IP traffic is not basically saying we're excluding non-IP traffic from the Ethernet stuff.
Right.
Okay, cool. Thank you.
Anything more here? This is an open issue. I am proposing that there needs to be discussion on this open issue. If I had the solution, I wouldn't have opened an issue. I'd have updated the document. Alex.
Alex Chernovsky, Google. So my concrete proposal here, which I sort of outlined on the GitHub issue, which I'm going to say here to be provocative to hope that someone actually replies, is we should probably say what you should do, but not do anything which is sort of mandatory to implement here, except for maybe saying you can do full-size MTU over reliable streams, since I think fragmentation is more evil, and basically tell people that implementations should, and I do mean all caps should, try to get into a world where they don't have to do that.
Ben?
Hey, so yeah, I think it would be like the logically correct thing here, I think, is that we're creating some kind of virtual interface where we need to just like expose the right MTU off of that interface. And that actually reflects the characteristics of the link. And so like, I think normatively that's what we should require. And then, yeah, we can recommend different strategies of like, should you should you choose a bigger one and do internal fragmentation or send large packets over capsules or whatnot. But the normative thing, it should be that the indicated metadata should reflect the observed behavior.
Yeah, there's a couple of things that can get interesting there. For instance, if you bridge it to a physical segment, now you're bridging things with two different MTUs, and things can get weird. Also, quick connections, for instance, can get rerouted, and the path MTU can change. So you get to update that on the fly. That's going to be a problem regardless, but
Lars?
Hey, Lars Eggert. So I have a simple suggestion, which is to do the absolute simplest thing that works for the use cases that were originally presented and no more, rather than like trying to build the perfect beast here. Right. The other thing that we can do is we recognize this is much harder than we originally thought and drop it. Just putting that out there as an option. I'm in the proposal.
Brian?
Yeah, so I +1 to what Ben said, +1 to what Lars said. I think I would add to that as a principle, we should avoid adding fragmentation at this layer. I wouldn't say at all costs, but like fragmentation is one of those things that you think is going to fix your problem and then end up now you have like 6 problems. It's like the regular expressions of networking. So let's just not do that.
Miria?
Mia Kulevin, I think we should not describe any of these hacking in the document. I mean, if somebody really wants to do it, then they can probably still do it. So by default, I think you just have to drop the packet. We could figure out if there's any kind of solution that we can do on the mask layer that actually helps the problem somehow. But, that's just like additional effort. So I'm not sure we need it.
Mm-hmm.
Is there anybody who would find their use case or otherwise be very upset with the drop the packet approach? Sounds like we have several suggestions to do that, but not a lot of people pointing out problems with that. So maybe let's take that as input and keep going. Yeah. Onwards. Mm-hmm. Oh, I see Christian joined the queue.
Can't hear you.
Yes, my mic was muted at the mic. That's weird. I was saying this business of sending messages that are larger than the MTU is very common in media over QUIC. And the consensus in media over QUIC is don't try to use datagrams for that. Effectively use short unidirectional streams, because short unidirectional streams have many of the property of datagram that we want, like no head of queue blocking and things like that. And that might be a better deal than trying to use fragmentation on top of datagrams, etc.
Zahed?
Yeah.
Jahed. So I kind of agree with what Miria said, like we should not do engineering or try something hacking to solve this one. If there is something that we could do in the mask to help it, that makes sense. We should do it. And I also not sure, like, because Eric wanted to, like, if we drop, what are the problems there would be? I'm not sure, like, we have enough expertise in the room to actually judge that. So maybe we should reach out to the people who has been doing tunneling, Ethernet tunneling previously in IETF. That's kind of like what my suggestion would be. So please involve like others that we have already done that, or like seek for expert opinions. Unless I'm wrong, people here are like disagree with me, like we are lacking some sort of expertise on these dropping these packets. Please shout out.
Alex, and then let's keep going.
Hi, it's Alex again. I want to address the idea that Christian just proposed. So the initial implementation for Connect IP, which was called Cubone, did in fact do the entirely short-lived streams thing because it predated datagrams. It's great. It works. It won't work here because we're in the context of HTTP, so we can't go and create new streams easily, right? It's a pain in the butt. I don't think that that changes the semantic of like just throwing it on capsules on the existing stream that we have. I know Martin in chat raised the concern about performance problems, but I think ultimately the question really here boils down to there is a network that we're connecting to which has an existing MTU. We need the interface MTU to match, quote unquote, and the behavior needs to be consistent. If we're talking about IP traffic, PMTUD will probably work and you can get away with making it smaller. If we're talking about other protocols where we don't know what their behavior is in the process of dropping these frames, we don't really know what's going to happen. So like my personal opinion is we should probably try to see if we can get away with doing drops. And if we can't, put them on reliable streams, but we probably need implementation and real data to actually make this decision. So I think I changed my vote to how about we actually get some concrete implementation data and come back to this issue when we have that rather than purely ideological discussion. And I agree with Zahed, we should get more input. And I think this is one way to force that question.
Right. Thanks. Hopefully the others will go quicker now. So last time we'd also talked about some MAC address filtering. Do we want to dig deeper into this? Like it was mentioned briefly last time. Do we want to do something like a server MAC address assign like the IP address assign that Connect IP has, or just let each side decide what MAC it's using?
Yaroslav Rosamaho, it really feels like implementation detail rather than protocol specification, unless we're looking to signal some filters in the protocol, which I don't think is the intent.
Filtering was mentioned last time as a potential interest, which is why it's here at all.
Lars.
Lars Eggert again. So for this and for all future things, so I don't have to get up to the mic again, I would prefer we do the absolute simple most thing, which is not do anything here. And if somebody needs it later, we reopen it or we do a biz or we do whatever. So let's keep this simple.
Sounds good to me.
And actually, to respond to Lars David Skenazy, I think a lot of these issues were filed because folks asked questions, but I think I'm strongly in support of what Lars said, which was even if they asked a question, maybe the right answer is, that's great, we can deal with it later in an extension. So I would, for this and a lot of the future ones, that's probably what we should do unless we have ones where we think it won't work.
Mm-hmm. All right. This was a question, I think it's entirely out of scope. We can figure out an answer to it later if we want. We cannot, but it was asked at the last meeting.
I think this is a place where if we have demonstrated folks with use cases that need it and et cetera, if we've met that bar of this is worth the energy, let's maybe talk about it. But otherwise, I think having written it down and then saying, hey, if you'd like to be a proponent of this, please come and actually bring that. Otherwise, it's going to sit and be closed as for future work if anybody needs it.
Yeah, and I think a bunch of these might fall under that category as we go forward.
That is a lovely theme. Let's keep it going.
Never mind. I'm standing on an extension point. I don't need another one. Other layer 2 things can do different extended connect. It's fine. This is an implementation detail. I don't think we actually need to talk about this. I put the slide there for a reason. It wasn't a good one. Frame delivery order. This one is actually a little interesting. I've been digging into pseudowire 3, and they were pointing out in their work that Ethernet doesn't have a guaranteed delivery order, except maybe when doing link aggregation. I think this may also be a knob that could be tweaked, and perhaps we can send flows down their own streams or something if we need guaranteed delivery order, but probably for the most part, we don't care. If someone wants that knob, they can shout. Also, a thing I noticed while reading the pseudowire stuff, they don't send pause frames. There's probably a good reason for it. Perhaps we should not send those either. And then, like, what do we want to do about VLAN tagging? The easiest thing is to ignore it and just let them through, but we could do more interesting things with it, potentially. That could be more extension work. And that's racing through all those things.
Beautiful. Thank you. I think so. If we're summarizing where we are, other than administrative procedures and things, there were a lot of different questions and concerns raised in the previous conversations. It sounds like as a group, we are comfortable in an approach of let's be absolutely minimal. Anybody who wants to come bring an additional further extension to this somewhat extension can certainly do that and bring that activation energy, but we aren't trying to go grab all the things. We're trying to do the smallest thing we can that will fit this particular use case that we decided to take on. It sounds like I'm seeing some thumbs up and otherwise generally happy expressions. In which case, beautiful. Thank you very much,
Cool.
sir.
And if there's nothing else.
All right, we have one
There's
last
nothing
as time
else.
permits presentation from David.
There is nothing else.
There is another
I have a
thing.
question regarding the proxy Ethernet part. Can you go back a little bit slides to the concern of the FCS part, frame checking sequence, FCS? No? Yes, this is the one thing here. Because there is the one scenario in the Ethernet PTU session type in 3GPP. Basically, it said on the Ethernet tab from the UE side, it's going to strip off the preamble and FCS, and then it's going to send out. If we're using this proxy, if you have both there, that means in that case, we may have trouble. There's a spec in the 5G already.
Let's talk offline.
Yeah. Well, I can tell you that there's really something there already.
All right.
Sounds good. Thank you very much. All right, this last presentation is deeply into as time permits, so this is not something that we're necessarily considering adopting or anything this time around. But as we've been talking about, our general strategy right now is the remaining work items in MASQUE are the things that you need in order to make MASQUE actually work in real life for real people. And so this is an extension that we previously considered, and there are now apparently real people who have real lives that are not in this room who have needs. And so this is a preview of something that we may want to consider and hopefully spark some offline conversations, help make concrete, and then we can talk about in future meetings. Would you like me to share slides for you, or did you bring your fun little gadget that does that?
No, if you could, that would be easier. And by fun little gadget, you mean the phone that your employer makes?
One of those things, yeah.
Yeah.
Or yours.
All right, thanks. Well, I think Eric covered the overview here. Perfect. So I wrote a draft and I submitted like at least 3 hours ago, so I hope everyone in the room has had time to read it. Next slide, please. But no, so this came out of a discussion with the Chrome OS team that happened after the draft deadline, so I figured I would just present the overall idea. But anyway, most VPN protocols today allow you to exchange DNS configuration information inline. Mainly, what is the IP address of my DNS name server? You also have other cool things like split DNS. These domains go through the VPN, these don't. Or search domains. Next slide, please. And that's, like V2 does that, OpenVPN, all the things. Connect IP doesn't do that. We talked about it in the early days of working on that draft, and kind of there was a lot going on. So we decided to really, our kind of design principle for Connect IP was what is the minimum we can do to support a few use cases. So we kind of punted it and said we can always build it later as an extension using capsules. Well, the future is now, it is later, and some folks were asking for this. So next slide, please. What do? The problem is that if you don't have this and you want to build like a personal VPN using MASQUE and Connect IP, you're sad because you have to exchange that as your configuration information, and that's kind of really annoying, especially if these addresses change. Next slide, please. Luckily, and I've discovered how to use AI to make images, watch out, you can just shove the DNS configuration information in a capsule and then you're happy. And next slide. And that's pretty much the entire idea of the draft is there's a capsule to say, hey, can I have DNS configuration information, please? Here's your DNS configuration. Have a nice day. It mimics what we did in Connect IP for IP addresses. It also does split DNS and search domains because like I did a little bit of research on what other VPN protocols use and people thought those features were useful. And that's kind of all there is to it. Next slide. And that's it. So the idea is, do people think this is somewhat useful? Do you want to know what I typed into Gemini to get those stupid images? But like at some point, please read the draft. If people think this might be worthwhile and worth the working group's time, I'd like to see where this takes us, but we have time. Martin.
Yeah, keep it snappy. So the signal we're really looking for here is this worth the time and energy?
So I'm not sure that I'm entirely happy with the idea of doing DNS over yet another thing when we already have DNS over HTTP, and that is what we're doing with all the UDP. So
well, no,
why does that not work here?
So the idea is this is how you send DNS through MASQUE, because you're right, we have ways to do it. This is, you're trying to set up a VPN. So you brought up a TUN device on your client that's going to tunnel part of your traffic, and you need a way to say, send my DNS through the VPN. And like that's what every platform supports. Otherwise, you're just leaking your DNS out onto the, yeah. That's all there is to it, really. It's like, what is the IP address of my DNS name server?
Yeah, there's other ways to do that. If we only give them a DO endpoint, we can just use a URL, right?
You could, but like at this point, like that bit of OS code doesn't have DO code, and so that would be nice. But like right now, all it like what it has is resolve conf.
Fix that.
Yes, and
Lars,
a half-serious comment going completely other direction from what Martin just said is you could just tunnel DHCP and you get everything.
So that is another option. We explicitly decided not to do that when we built Connect IP. We could have built Connect IP that way. That's how WireGuard works. But we decided to exchange the IP addresses. So I mean, it's not a crazy way, but that's not what we decided to do. Tommy.
Tommy Polly, as someone who for IPsec wrote the way to like not have to do it through DHCP, I am sympathetic to this. I think it's fine. Like that's like the way that Ben on List was describing how he would be using Connect IP is more like how I want to use Connect IP, but I get that there are some use cases that are like this. So like, sure, fine. I do want to make sure that I haven't read the draft because it wasn't posted, but how dare more recently with like IKE, we have this stuff related to ADD about making sure you can communicate the encrypted, like the equivalent of DNR in this. So you are signing up to do all of that too, because this is yet another place to put like the name and the SVCB stuff. So if you're willing to do that, sure.
Yeah, job security.
Mark.
Mark.
Hi, Mark Smith. One of the key differences between V4 and V6 is that all the links are treated the same. There's no IPCP as there was in PVP. So long story short, VPNs are just another link type and RAs and DHCP V6.
They are, but
You can, well, I'm just saying that's the,
no. So
that's the IPv6 model. So you see it across Token Ring, Ethernet,
absolutely,
PVP, frame relay, all
that is true. But for like even IPv2 tunnels, like you explicitly say, you don't send RAs. We send the configuration or IPsec tunnels that are configured using IPv2. You say I exchange the configuration information using IPv2. Don't send RAs. That's what we said for Connect IP. I think we have explicit text saying not to send RAs. So it's. I agree that that's how you could build it. You're totally right.
That's supposed to be the model.
Yep.
In IPv6. Okay, so if things aren't doing that, they're coming up with their own versions of.
Yeah. I mean, IPv2 was done way before my time, right? And so.
Well, but yeah, anyway, I'm just saying the way
fair.
IPv6 expected.
And Ben.
Hey, Ben Schwartz. We're at time. I'll just say, I think we should at least weigh that option against this one. Basically, in addition to what I really want, like overarching configuration, another option to test against this would be a like DHCP or RA mode for Connect IP or profile.
That's an option. I mean, that's not something we would love for our use case, but worth considering for sure. Thanks. All right. Thank you, everyone. And please read the draft at some point. Let me know what you think. And otherwise, we'll discuss it on the list.
Beautiful. Thank you all. Thank you to our note takers especially. And have a great rest of the week. Saw that. It's beautiful. So the dotted line is like basically fuzzy data that isn't all the way in yet. Nice.
You can just make another fold and then stop the thing.
Got it. So like that's a real noticeable spike though. Right. Yeah. I saw that. Nice. Yeah. Thank you. That's beautiful. Yep. Hopefully it will soon. But yeah. Right. Right. Okay. Yeah, that makes sense. Okay. I'm trying to write down things I need to do, and then I will have brain space to think. But thank you. That is beautiful. Thank you.